and the zona pellucida, thus clearing a path for a sperm cell to reach the oocyte membrane. All right, so that's it. Now, what is the acrosome? Does everybody know what the acrosome is now? What is the acrosome? The acrosome is the tip of the who? Spermatozoa. All right, spermatozoan. The sperm. That's the acrosome. That is the acrosome. Why is the acrosome important? Why is the acrosome important?
It contains the enzymes that break down the coronary.
Right, it contains the enzymes. Why does it take millions of sperm cells? Because it takes millions of sperm cells to release enough of these digestive enzymes to break down the corona radiata, the zona pellucida, and to get in there to the female, what's called the female pronuclei. That's why it takes all these enzymes. All right, so everybody, could you answer questions like that? Everybody understand that pretty good? Any questions? All right, now, right here, here's another thing. Block to polyspermy. Okay, now, in other words, and I used to wonder about this when I first started teaching this class many, many years ago. If there's so many millions of sperm cells, why does only one normally get there? What stops it? What keeps the others out? If they're just flooding the situation, what keeps the rest of them out? Well, actually, there are two theories on this. Block to polyspermy. All right. One, when a sperm cell, when sperm cells or a sperm cell comes in contact with the oocyte membrane, then sodium channels open, which okay, now look. A polarized membrane, everybody. Who's on the outside on a polarized membrane? Sodium or potassium? Y'all remember this from nerve and muscle? Y'all don't remember this from 2401. In a polarized situation, the sodium ion is outside. Y'all remember? The sodium ion outside. When the sperm cell comes in, I guess it chooses. What if they all get there at the same time? How does it choose one? How does it choose one? It says sodium channel open, which depolarizes the membrane of the oocyte and blocks the entrance to other sperm cells. They say, well, what about if they all get there at the same time? Well, there's a slow block to polyspermy, there's a fast block to polyspermy. But now, if they all get there at the same time, that's a good question. But sometimes, all right, but anyway, it says right here, this is called the fast block to polyspermy. In other words, sodium channels open, sodium moves in, which depolarizes the membrane of the oocyte and blocks the entrance. And I'm not sure they understand that for sure. I'm not sure on that one, but it does. It blocks the entrance. This is fast block. Reactions which result in the hardening of the zona pellucida are referred to the slow block. In other words, after one gets in, there's also a slow block where the zona pellucida hardens and doesn't allow anybody else in. It's all kind of a mystery. It's all kind of mysterious, but that's what they say about it. You can read it in your book. If you have a book, just kind of glance at it, read over it. But there's the block to polyspermy. Just allow one to get there and fertilize. And it's called the male pronucleus. And when the male pronucleus fertilizes the female pronucleus, or comes in contact, that's the true moment of fertilization. And that secondary oocyte will produce a polar body, which disintegrates. And so we just have right here, involves the release of calcium. That gets pretty, I don't ever emphasize that. That's a slow block of polyspermy. Now, the sperm enters the secondary oocyte. This signals the oocyte to complete meiosis II, as we've talked about. Who is fertilized? The secondary oocyte. Secondary oocyte is fertilized, and that forms the ovum nucleus. Sperm enters the secondary oocyte. This signals oocyte to complete meiosis II and form the ovum nucleus and one polar body. Ovum and sperm swell to become the female and male pronuclei. Fertilization occurs when the pronuclei fuse to produce a zygote. So there's a male pronuclei and a female pronuclei. They unite, and that is the zygote. And so that's the way it goes. Then it goes from there. A zygote occurs. Where does this normally occur? In the upper third of the fallopian tube. Within a certain number of hours after fertilization, the first cleavage. By the 6th day, the thing is in the form of a blastocyst. It normally implants in the uterus 6 days after fertilization. And there goes the scenario right there. Now, another thing right in through here, everybody. Another thing right here. And you know the marula formation, mitosis of the fertilized egg. Mitosis is called cleavage. I think everybody understands that. And each one of the cells is called a blastomere. Everybody understands that. All right, let's move on with this just a little bit. Cells produce, there that is. We talked about that in lab. All right, first cleavage end of 36 hours, second cleavage end of the second day, end of the third day, 72 hours, 16 cells. That's possibly the marula stage or marula stage. Okay, marula solid ball of cells. Blastocyst, that's a hollow ball of cells. That is what enters the uterine cavity. The blastocyst enters the uterine cavity. That is what's going to implant about 6 days after fertilization. I'm going to ask you some of these timelines, a few of them, so highlight them for the final. All right, and then right here, the blastocyst consists of the trophoblast or trophectoderm, that's the outer covering of cells. I don't think I put on your note material right here the inner cell mass, which will develop into the embryo and a fluid-filled cavity. I don't think I put here now. Okay, there you have that right there. There's the inner cell mass. There's the blastocyst cavity. The word trophoblast right there, that's that outer. I don't think I put on here. Let me just see something this minute. It begins about 6 days. Okay, enzymes secreted by cells of the trophectoderm enable the blastocyst to bury in the endometrium. Trophoblast cells begin to produce there it is right there. I'm not going to ask you about the trophoblast being made up of the cytotrophoblast and sensitrophoblastic. I'm not going to ask you that, but it is, and that will eventually form the placenta. But the thing is, the trophoblast cells that's what produces the human chorionic gonadotrophin. And this promotes the corpus luteum to continue to secrete progesterone, which that is absolutely necessary here. And you know, people, I think sometimes people that want to get pregnant early on can't get pregnant, keep having abortions, spontaneous type of abortions. It's a hormonal thing. Something it doesn't allow, in other words, they're not producing, something is not maintaining the corpus luteum. If the corpus luteum is not maintained early on, a person cannot maintain a pregnancy. That corpus luteum has to be maintained to produce progesterone. What causes that early on is the human chorionic gonadotrophin. So all kinds of things can go awry. You know, not very often, but normally. I mean, not very often, but seldom. You know, every now and then, things can go nuts. And I kind of had that right there. There's those terms, though. The trophoblast area. Trophoblast is actually made up of this cytotrophoblast, sensitrophoblastic, and right in here will form. I think light's just about all gone there. Right in there will form most of the placenta, or the chorion, which makes up most of the placenta. In fact, I have right here, I have something like extraembryonic membranes. The yolk sac. The yolk sac is an endoderm line membrane. It's small in the human. And it becomes actually the yolk sac. Now, why, everybody, do humans not bleed like an egg, like a bird? The yolk sac, because that's where they get. That's where the egg. That's where the young is nourished by the yolk. What about a human? The yolk sac is pretty much nondiscrete because we are placental mammals. Y'all understand that? We are placental mammals. So very early on, the developing young begins to get nourishment from who? The mother, through the placenta. So the yolk sac becomes a non-functional part of the umbilical cord, the yolk sac. So I wanted you to make sure you understand why the yolk sac is pretty much non-functional. I mean, it offers a little bit, but not much. And then, right here, the amnion. All right, what do you know about amnion? Just from some of you being mothers, what do you know about amnion? Ever heard of amnion? Ever heard of amniocentesis? Or if I'm pronouncing that right? Heard of amniotic fluid? In other words, they can check amniotic fluid for there'll be cells in there. They can check that for chromosomal abnormalities, right? Chromosomal abnormalities in the amniotic fluid. The amniotic fluid directly surrounds the embryo. Okay, and so the amnion surrounds the embryo and becomes filled with the amnion fluid. In other words, they say in the country say, well, our water's broke. You know, the water broke. Well, the water broke, what that means, that's the amniotic fluid. That's what that is, the amniotic fluid. Alright, so it serves as a shock absorber and so forth. Now the chorion is derived from the trophectoderm of the blastocyst. That's the chorion. Now, I just mentioned this to you. It eventually becomes the principal part of the placenta, produces HCG, which can be detected in the urine. Now, okay, y'all, see, it can be detected from the middle of the first month. In other words, just within a few short days. Any of you know how soon, for sure, how soon after your doctors told you, how soon after a missed period you could detect human chorionic gonadotrophin? How many days? Anybody told y'all? Nobody? Okay. Well, it's just a few days.
Yeah,
Within a week or so, about a week or so after a missed period, the human chorionic gonadotrophin can be detected with a pregnancy test. Yeah, and the human chorionic, so it produces HCG, you know, in the middle. That's a week. That's about a week and a half maybe. It's detecting. All right, and HCG, of course, maintains the corpus luteum. What does the corpus luteum produce? Progesterone. So there you have that sort of business right in through there. All right, the allantois is responsible for, I never knew much about the allantois. Responsible for certain blood vessels and that sort of thing, and that is the allantois type thing right in there. So there is that. There's that. That's just showing. The rest of this is just some of these things that we've been talking about, and that is the idea along those lines. All right, now then, that's about it.